Hello everyone, in this video I am going to explain about Hartley oscillator. Let's discuss how the Hartley oscillator is constructed. So we have the resistance R1 and R2 which provides DC bias to the transistor, and we have two coupling capacitance CC1 and CC2, and then we have an emitter bypass capacitance, and the feedback network consists of the inductor L1, L2 as well as the capacitor C. So the feedback network consists of the inductor L1 and L2 and capacitor C, which determines the frequency of oscillation. So once you give the supply voltage VCC, your capacitance gets charged. So once the capacitance is fully charged, it starts to discharge to the inductor coil L1 and L2, and it sets up the frequency of oscillation. So the frequency of oscillation for the Hartley oscillator is given by 1 by 2 pi square root of L equivalent into C, and L equivalent is given by L1 plus L2. In order to find the frequency of oscillation, so from the circuit we can write Z1 as j omega L1. So it is a inductive reactance, and Z2 is a j omega L2, and Z3 is given by 1 by j omega C, which can also be written as minus j by omega C. And the general equation for the oscillator is given by HIE into Z1 plus Z2 plus Z3 plus Z1 Z2 into 1 plus HFE plus Z1 Z3 equal to 0. So HIE represents the input impedance, and Z and HFE is the current gain. So we have to substitute Z1, Z2 and Z3 in equation 1, and we can find the equation has HIE. So you just take j omega as common, and here j into j becomes j square becomes minus 1. And then once you get this equation, we have to determine the frequency of oscillation, we have to equate the imaginary part as 0. So this is your imaginary part and these are your real part. So we have to equate the imaginary part as 0. Imaginary part is HIE omega L1 plus L2 minus 1 by omega square C, which is equal to 0. So we have to equate it to 0. So once this HIE omega goes to this right hand side, it becomes 0. So L1 plus L2 minus 1 by omega square C, which is equal to 0. So what you will get for omega square? Omega square is equal to 1 by L1 plus L2 into C. What is omega? Omega is given as, omega is equal to 2 pi f, right? So f is given by 1 by 2 pi root of L1 plus L2 into C. What is L1 plus L2? It is L equivalent. So we can write f as 1 by 2 pi root of L equivalent into C. So once we find the frequency of oscillation, we have to find the condition for oscillation. So to determine the condition for oscillation, the real part is equated to 0 from the equation 2. So to find the frequency of oscillation, we have equated the imaginary part as 0. So to find the condition for oscillation, we have to equate the real part as 0. So this is the real part. So once you equate to 0, so this term, if you just move to that side, it becomes positive. So we have to substitute the value of omega square from equation 3. So from equation 3, we have got the omega square. So once you got omega square, you can substitute the omega square in this equation. So omega square is 1 by L1 plus L2 into C, and here you have L1 L2 into 1 plus HFE, which is given by L1 by C. So here C and C gets cancelled, and then you just write the remaining term and then cancel out this L1 as well as L1 here, and then write the remaining term. You will be having L2 by L1 plus L2, which is equal to 1 plus HFE. So we can write L1 plus L2 by L2 has 1 plus HFE. So here we can write this as L1 by L2 plus 1, which is given as 1 plus HFE. So then we can neglect this 1 and 1. So HFE, the current gain, is given as L1 by L2. This is the condition for oscillation for the Hartley oscillator. Thank you for watching.